We continue Unit 14b, Simplifying Rational Expressions. To do this, we factor the numerator and the denominator completely. And we divide or cancel out all common factors. Let's look at example 1, 4x cubed, y to the 4th, divided by 12x to the 7th, y squared. This is a rational expression because I have a fraction in the form of a polynomial divided by another polynomial, where q of x cannot equal 0. Let's start to simplify by breaking down these numbers into their lowest possible parts. Or the prime factors to 4 are 2 times 2. X cubed is the same thing as x times x times x. Y to the 4th is y times y times y times y. 12 is 2 times 2 times 3. X to the 7th, there are 7 x's and 2 y's. Now remember, we can cancel fractions. If we have a number on the top that's the same as the number on the bottom, we can cancel that fraction out or divide it out, because when we have a number on top and a number on bottom, it's the same thing as saying 1. 2 divided by 2 is 1. So these 2's will cancel, these x's will cancel, these x's will cancel, these x's will cancel, these y's will cancel, these y's will cancel, and that just leaves on the top 2 y's, so y squared is equal to a 3 and 4 x's, so that's x to the 4th. So there's your answer. The other way to look at this is to remember that you can subtract the exponents if you remember your exponent rules. The rule we will be looking at is when you divide like bases, subtract the exponents, and the base stays the same. So we take the same problem. 4 goes into 12 3 times. Notice 3 is smaller than 7, but both these x's are the same. They have the same base. So I'm going to bring the 3 to the bottom and subtract it from 7. And the 2 I will bring up and subtract it from 4 on the exponent to y. So y 4 minus 2. So the problem is y squared over 3x to the 4th. Same answer, just using exponential rules to find it. Let's look at another example. 8x cubed minus 2x squared divided by 4x squared minus x. Remember, the most important piece to simplifying is pull out the GCF first. So looking in the numerator only, the GCF between 8x cubed and negative 2x squared is 2x squared. When you pull 2x squared out, you're left with 4x minus 1. On the bottom, the greatest common factor is x. X goes into 4x squared, 4x times x goes into negative x, negative 1. Notice something nice happens here. On both top and bottom, I have 4x minus 1, so those will cancel. Also notice on top I have 2x squared. Now this is the same thing as 2 times x times x. That means I have an x on the bottom and an x on the top that I can eliminate. So our answer is just 2x. I'm going to look at 8x cubed minus 2x squared again in another way. Remember to break down these into prime factors, and 8 breaks down to be 2 times 2 times 2. X breaks down to be x times x times x. This 2 breaks down to be 2 and 1. I'm not going to write the 1. And x squared is x times x. we want the greatest common factor that we could pull out. Notice they both have a 2, and that's it. So 2 is the greatest common factor among the coefficients, the numbers. Now let's look at the x's. They both have one x. They both have another x. I'm going to put this down as well. That's it. So 2x squared is the greatest common factor. Now open up parentheses and we're going to multiply 2x squared to whatever's left over. Well, what is left over in this problem here is 4x. 2 times 2 is 4x. And there's nothing left over here on this side. But remember, we need to have a 1 there. So when we multiply 2x squared times 4x, we get 8x cubed. When we multiply 2x squared times negative 1, we get negative 2x squared. Let's look at example 3. Notice in example 3, I need to simplify this rational expression. There are 4 terms in the numerator, so we will factor by grouping. The most important thing to do is pull out the GCF, but there is not a GCF in the numerator. So then I just go to grouping. So I will group the first 2 terms together, then the second. I could pull out a 2x squared in the first parentheses. When I divide 2x squared into 2x cubed, there is an x left over. When I divide 2x squared into negative 6x squared, it will go negative 3 times with nothing left over, so x minus 3. In the second grouping, I could pull out a 7, and that also leaves me x minus 3. On the bottom, x squared minus 9 is a difference of 2 squares. It's 2 terms. So that is x plus 3 times x minus 3. Now I'm not done yet. I still haven't completely factored. Notice there is something in common between this term and this term. Both of those terms have an x minus 3, so that pulls out. What's left over stays inside parentheses, and we just combine them. 2x squared plus 7 over x plus 3 times x minus 3. At this point, we can cancel, and that leaves 2x squared plus 7 over x plus 3.